The way I greet you guys have got to tell you my mood. So right now, I want you to tell me, what mood am I on? Everyone. Okay, let's keep going. Let's keep going. It's 2.27. Again, it's one of those interesting exercises to work with. And if I don't even know if I'm pronouncing that right. Prime spelled backward, okay, is a non-palindromic prime number whose reversal is also a prime. For example, 17 is a prime and 71 is a prime. Okay, so 17 and 71 are MIPS. Okay, write a program that display the first 100 MIPS. Okay, display 10 per line, separated by exactly one space. Okay, as follows. Like if you used or if you watched or rather attempted the exercise 6.26, I forgot showing you guys my cover page of the textbook that I'm using. This is it right here. Okay, what I was saying is, if what we can possibly do is to use the algorithms we created, or rather methods we created for 6.26, right? We can use them. We can simply copy and paste them for the solution of 6.27. Okay, but you know what? I'm not going to do that. I'm going to do everything from scratch. Unlike before, I won't have empty methods up front. I wanna do it right now. So it's prime. Again, before we code, let's talk about the problem. We were told that it is a non-palindromic number, meaning it is a number that is not both prime and palindrome. Okay, so that's number one. So what is it that we want to do? Basically, we've got two tasks on hand and we're gonna map them to methods. Okay, the first task will be to tell whether or not a number is prime, and the second one will be to tell whether or not a number is palindrome. Okay, but you know what, I don't know, we can perhaps get away with this by having only one method, in which case we'll simply pass the number for the first time, and for the second time we pass it reverse. If both cases return true, then what? Anyways, let me keep going. The way will get clear along the way, okay, as I go on. Okay, so let's just, the mist will fade away as I go on. Okay, so one thing I know, we've got to tell whether or not the number is prime. Okay, and we're gonna do that by, this is my approach. Number might not be the best one, but I prefer doing things this way. Cool. Return false. We know the first two aren't prime numbers, so now let's start from and long 2, not 2. What perhaps divisor. Gonna start from 2 is divisor, less than or equals to number, square root of number. Remember folks, the reason why I'm using square root of, what we can do, I'm repeating this because I'm assuming not everyone have watched my solution on the is prime number. Okay, what we can do, we can simply go from divisor up to number and then divisor and do it like that. Most of us will think of this as a best solution, but it's actually not. A better one will do this. Okay, we won't go all the way up to it number itself exclusively, right? We will go halfway through. However, if we do go halfway through, we gotta include that number as well. And in an even better solution, will go up to the square roots of number. Okay, so that's why, gosh, that's why I'll simply do things like that. Okay, now what do I do? I'm checking if number is divisible by divisor. Then we know that that number is not a prime number. Okay, false. True, done. Oops, that was so stupid of me. The is prime method supposed to return a Boolean value. Okay, that was number one. Oh, now secondly, what we wanna do is to check again. I'll use my previous solutions, just that I'm against the whole idea of copying and pasting, but this is the same code that I had on exercise 6 is palindrome. On exercise 6.20 what? On exercise 6 what was it? 6.26. Again, I keep repeating this. It's not about the effectiveness and the efficiency of my solutions. I mean only on this chapter though, only on methods. The point there is I'm showing out how one can play around with methods. That's all. Okay. So you shouldn't get lost in the details and find yourself missing the point. Okay. Again, I've got a first convert string dot value of number. Essentially, I'm converting a long variable to a string variable. Okay, what else do I want to do? I want to create two right index. I'll initialize it to word dot length. Int left index, I'll initialize it to 0. So basically this method compares the last and the first characters. If they happen to be the same, we'll compare the second one and the second last character. If they also the same, we'll continue the process until either the right index is less than the left index, or we have found the two characters that aren't equal. Okay, that logic is pretty straightforward, I presume. Again, you can sit down with the pen and the paper, which are I'm still stuck on my previous solution. We're no longer working with high and low. We're working with right index and left. As long as right index is greater than left index. Okay. I don't even know what is it I was saying. So it's better I keep going and talk less. Okay. So if left index is not equals to, remember these are characters we're working on, so we can use comparison operators. Word.charts, comparing the two, the left character and the right character. Return what? False, regardless of whether or not the two are equal. What we'll then do is to decrement. Why do I keep writing high? I'm still, my mind is subconsciously still stuck on the previous solution. Okay, so left index has to be incremented. Okay, finally, in case we reach the end of the loop, immediately we know that we've got a palindrome. Okay, number. Now I want to write that method. In fact, you know what, for a change, let me simply put everything right here on my main method. So I'll display count. I'll create count, which will help me determine where to print my character, whether to continue printing on the current line or not. Okay, so number will be initialized to 0. Perhaps that's not the best choice, or rather, perhaps that's not the best choice, but can I show you one thing? It will work. It will definitely work. So while count is less than 100, remember we're starting from 0, so that's why it has to be less than 0. If we started from 1, we would have less or equals to. Okay, so basically this is the part we're implementing now. An env is a non-palindromic prime number. Okay, so it has to be a prime number if this number is a prime number and it is not a palindrome, then that's gonna be our guy. We're gonna have to display it. Okay, in fact, those aren't the only two conditions, right? we gotta take into consideration the reverse number as well. Okay, so right now I'll go is prime. Now I'm checking the reverse prime. Oh, by the way, this is the method that I haven't yet implemented. Okay, so again, the given number has to be a prime number. However, it should not be a palindrome, and also the reverse number has to be a prime number. Okay, let me start over. Let me repeat that, or perhaps rephrase it. I feel like I made a mistake or created a confusion. The current number, in order for it to be an MIPS, it has to be a prime number. However, it should not be a palindrome. And furthermore to that, its reverse has to be a prime number as well. Okay. If this is the case, what we're gonna do, we're gonna display it. Okay, you know what, before I continue, that's why I always like writing out methods I'm gonna work with first, and then later on do the implementation, because right now we're having that annoying compile error. We're returning a string. Oops, not a string, it's supposed to be a long. Okay, reverse the prime. We'll give it a prime number. I know we could get away with this by using a string, creating a string from the prime number, and then we simply read the string from right to left, but that's an inefficient solution. I know I've said before, I don't care much about the efficiency of my solution, but I thought, you know what, this time around let me do things differently for a change. Let me concern myself about reverse prime, about the efficiency. Okay, so I'll simply go while prime is greater than 0. Basically, we'll keep chopping numbers. Let me make you an example on this algorithm, folks. Suppose we've got 1, 2, 3, 4, 5, right? Or perhaps let me make this a prime number, 1, 3, 1, right? So firstly, what we want to do, we want to chop the 1. That's 1 then. The 1 on the right of 3, right? We want to chop it, and then once we've chopped it, in order to chop the second number, we've got to first multiply that 1 by 10 and then add the second number. What we'll then have is 13. Okay, after I've chopped 1, oh god, let me start over. We'll first chop 1, right? And our reverse prime will be 1. After I've chopped 1, we will multiply it by 10, right? So we're gonna have 10 now, because it's gonna be 1 times 10, it's gonna be 10. We'll then chop 3. We'll then add that 3. Okay, we'll then, since we've got 10 now, what we'll then do, okay, firstly we'll multiply, oh god, the first thing for us to do, we'll multiply prime by 10, right? We'll then chop the last number, which will be 1 on our case. We'll then add that into our reverse prime. We'll keep doing that till the end. Okay, till our prime number is greater than 0. You see, sometimes I think explaining causes confusion. Okay, it's better I do things. Oh, guys, you guys I know will grasp this. Okay, so I'll go reversed prime is equals to, I want to multiply it by 10. Then I want to reverse the prime. Then I want to add prime mode 10. It is super important in these cases to make sure if you don't clearly know the precedence of your operators, it's better you play it defensively, okay, by using brackets. That way you've got nothing to worry about. Okay, now I want to get rid of the last number on prime, so I'll keep continuing this process. Okay, in the end, what I want to do is to once the loop finishes, before it finishes, I wanna check if prime is 0, because that's gonna be the end of our loop. If prime is equals to 0, because you know what, suppose our prime number is 1, so 1 divided by 10 is gonna be 0. So that's the case, that's our stopping case essentially. Okay, yeah, that should be the end of that algorithm there. I know it took longer than I expected, and I think that was because I was talking a lot. So that's why I gotta make sure on my coming videos I do more coding and less talking. But you guys, it's better. That's why I always suggest people give me their advice. You see, just by only watching, I don't know what works better for you. If you only watch, you wanna watch my videos, give me a thumbs up or a thumbs down, or just be straight with me. Say whatever is it that comes on your mind, okay? I won't get offended by anything. So please, I know some of you out there are probably find it okay for me to talk as I'm coding, and then some think, you know what, that makes me less productive. Okay, so please let me know. I want to do whatever that works for you. If you want to ask me to do a little coding and more talking, I'll do so. And if you want the exact opposite, I will do so as well. I'm okay with anything. Okay, print number. Okay, then I stop. Else system.out.print. I'll do that as well. Okay, our guys were grading me, some guys we grew up with, so I had to give them my attention. Okay, enough of that. Now that we've got that out of the way, the only thing that is left for me to do is to increment my number variable. Number. Okay, everyone. Let's hit the run button now and see what we get. Really? I forgot saving that. Let's start over. These better be the right numbers. 13, 17, 31, 37. Okay, up to 1, 3, up to 30, 49. Oh, they didn't show us that. But let's check out the first two lines. It seems like we have a working solution, you guys. I'll see you on the next tutorial. Next solution. Again, you guys, please let me know. I really want to hear your comment. Tell me anything you want to tell me, okay? I know I'm way too slow. Tell me about that. I know sometimes I can be annoying you. Also, tell me about that. I don't care, you guys. Because what we want to do right here is to benefit out of this whole Manikwe School thing. So that should be it for this tutorial, you guys. I'll see you on the next one. I'm gone.